Good morning, good afternoon, or good evening. Welcome to A Level and EP Physics. In today's lesson, we will discuss past paper questions from May June 2025, paper 1, variant 1. As always, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. And if you have any questions, please leave your questions in comments and I will try to answer as soon as possible. And if you're looking for extra resources, you can also join Patreon. On Patreon, you will see past paper, solutions, PDF, topic-wise questions, revision guides, and other resources. Question 1 says, which quantity is a vector? So vector quantity has magnitude and direction. Now, if you look at given quantities, pressure is a scalar. To describe pressure, we don't need to talk about direction, so it's a scalar quantity. To describe temperature, we also no need to talk about direction. Means we don't need direction to describe temperature. So this is also scalar quantity. Weight is a force due to gravity. So it's a vector quantity. So when we talk about force, we say force can be to the left, force can be to the right, force can be down. So weight is a vector quantity. Work is a scalar. It's not a vector. So the answer for this question has to be 6. Second question says 4 students A, B, C, and D have completed an experiment to determine the acceleration of free fall G. Each student repeated the experiment 3 times. The determined values of G are shown in the table. Which set of results has a high precision and a low accuracy? So first of all, we need to understand what exactly is precision. Precision simply tells us how close the readings or measurements are to each other. So it means that it depends on the range. So if the range is narrow, it means high precision. So range, if it is narrow, it means high precision. If it is not narrow, if it is wide, it means low precision. So this tells us high precision. So we can write down here. So this will tell us high precision. If the range is wider, it means low precision. So we can write down here low precision. Now for this question, high precision, we have to find out which data set has high precision. So it means the range should be narrow. The narrowest range has the highest precision. Now the second thing we need to understand is about accuracy. Accuracy. What exactly is accuracy? It's linked with the mean value. How close the mean value is to the true value. So if the mean value is close to true value, it means high accuracy. We can say high accuracy. And if far means big difference between mean value and true value, that means low accuracy. Low accuracy. So for this one, we need to find low accuracy set of data. So it means difference between true value and mean value should be the largest. So simply you can find the mean value for each one. You can also find out the range of each data set and then you can compare. To keep it simple, not to spend a lot of time on this question, I will simply look at this data. For example, D, you can look at all data you can calculate. So for D, for example, I will be looking at this one. So what is the mean value of this? Mean value. So the mean value we can simply determine. So let's say the mean value that will be equal to 10.1 plus 10.2 plus 10.1 and this is divided by 0. So we can find out the mean value. So we have here 10.1 plus we have 10.2 and plus we have 10.1 again. So divided by, this has to be divided by 3 so we can find out the mean value. So the mean value in this case is 10.1 up to 1 dB. So mean value is 10.1. We can also find out the range of this now. The range of this one is the maximum value, that is 10.2 minus 10. So the range will be equal to 0.1. We can also find the difference now, difference between mean value and actual value. We have mean value 10.1, actual value is 9.81. So if we solve this one, we will get 0.9. And low accuracy, it means this difference should be the largest. So you can calculate for all of them, you will see this difference is the largest. And this range has to be the smallest one, means the narrowest one, because data must have high precision. So answer for this question has to be D. So this will be the answer. You can do calculation for rest of the data by yourself. result. Third question says the diameter of a ball is measured as 5.26 plus minus 0.02 centimeters. What is the absolute uncertainty in the volume of the ball? So first of all, we can start with volume of the ball. Volume is equal to 4 by 3 pi r cube. The fractional uncertainty in the volume means delta V by V has to be equal to 3 times the power of r delta r by r. And as these two are constants, when quantities are multiplied and divided and we are calculating the uncertainties, we can simply ignore, because this is just a factor, so it will be divided and multiplied by this one, so overall result will be the same. So simply we can ignore fast simplicity. So we need to calculate for this one delta V. So delta V will be equal to 3 times delta r by r. Now simply we need to find the values. We need to find what is value of V, what is value of delta r, what is value of r, then we can plug in and find the answer. So first of all, let's try to find out what is r. R is half of diameter, so this is 5.6 divided by 2. So if we solve this one, we will get 2.63 centimeters. So this is value of r. And volume we can all find out. Volume will be equal to 4 by 3 pi r cube. So we can plug in value. 4 by 3 pi times 2.63, and we can take cube of this one. We can find out value of volume. So here we will get value of the volume. We can also do actually without volume, so I will go to that point very soon. And we need to find out delta r. Delta r has to be equal delta d by 2. Delta d by 2 means here we have delta e. So this is delta d, that is equal to 0.42 divided by 2. So we will get 0.01 centimeters. So here we can write down 3, and volume is 4 by 3 pi r cube. We don't need to calculate this one. So here we can say this is delta r by r. From here, this r square, r cube, we can cancel with this one. So here is r square. Now we can rewrite this one, and this 3 we can cancel with this one. So we have 4 pi r square times delta r. So simply we need to plug in the values now. So we have 4 pi, and r in this case is equal to 0.63 square multiplied by delta r, that is equal to 0.01 centimeters. Now if we solve this one, we will get 0.87 centimeter cube. So this is delta V. So the answer for this one has to be B. So there are few points you need to understand. One is the difficult point, how to calculate absolute uncertainty of radius when absolute uncertainty of diameter is given to us. So simply you need to divide by 2. And this part you need to understand how to find the fractional uncertainty in the volume. So if you understand about these points, then rest is just simple mathematics. Question 4 says two vectors x and y are shown. What are the directions of x plus y and x minus y? So this is simply about vector addition. Now first of all, we can take this vector. So I can draw here, this is our vector x. I can also draw vector y using a different color. Let me try this one using a different color. So we have vector y. So this is our vector y. I'm trying to make it as accurate as possible. Now first of all, we have to find out x plus y. So it simply means that we have to add these two vectors together. So I will take this vector y. I will simply move this one. I will place this one here. So this is our x plus y. So what is our resultant vector in this case? For resultant vector, let me use red. From tail of first to the head of last. So this is our x plus y. So we can say x plus y. So the answer is A. Our answer is B. Now let's move on to the second part. We need to find out. So this is our x plus y. So we can draw this arrow here. Now for the second part, we need to find out x, we can say plus minus y. Negative factor. Negative. So for this purpose, we can take over vector. We can take this vector y. So let me move this one to here. And vector y has to be the negative vector. This has to be the negative vector. So the negative vector means we can just rotate this one by 180 degrees. So this is negative. Now we can move this one and we can place this one here. So this is minus y. So in this case, the resultant vector, you can see the resultant vector is from the tail of first to the head of the last vector. So this is how we can add them together. So here this one is x and this is minus y. So this is x minus y. So the resultant vector is this one. Now if you look at the given options, answer should be B. Question 5 says a ball is projected vertically downwards with an initial velocity of 20 meters per second. A resistance is negligible. What is the displacement from its initial position of the ball after a time of 1.5 seconds? So simply we can imagine this is our ball. It is thrown downward with initial velocity of 20 meters per second. And we need to find out what is the displacement when the ball is here and the time passed between these two positions. Delta t is equal to 1.5 seconds. So we need to find out the displacement from this point. So we can simply take downward as positive. So our answer will be positive. Now for this one, what we have value of u that is given to us, value of t is given, and also we have value of acceleration due to gravity d. So we can simply use s is equal to ut plus 1 half at square. Now in this case, we have taken down is positive, it means this one is positive, and acceleration is also down, which means d this is equal to 9.81 meters per second per second. This one down, this is also down. So this value also will be taken as positive because we have taken down is positive. You can also take up positive, so these two values will be negative. So s in this case will be equal to 20 times 1.5 plus we have 1 by 2, so 9.81 times 1.5 squared. So if we solve this one, we will get 41.0 meters. So up to 2sf, this is 41 meters. So that's all for today's lesson, and I'll try to upload remaining questions before your final exam on 11th of November. If you have any questions, you can leave your questions in comments and I will try to answer as soon as possible. And I have also uploaded a lot of paper 1 questions on the channel. So you can go through those papers and those solutions. If you're not clear about any point, need clarification, you need more detail or explanation, you can leave your questions. See you in next video.